This is part 3 of the Energy Reactions Lab. Now, if you recall from part 1, what we were doing was we were using electricity to separate water into its two components, hydrogen and oxygen. So here we have this equation, H2O. That is our reactant, but it's not our only reactant. If you recall this setup, we've been putting electricity, which we're going to call energy here, into the equation for the last 20-some minutes. And then we have the arrow, that's where the reaction is taking place. That's the stage that we're at right now, where energy is going in and the energy reaction is taking place. And we are going to produce hydrogen gas and oxygen gas. And I'm also going to try to prove to you or demonstrate to you that, in fact, we did produce hydrogen gas. So I'm about ready to turn off the electricity, so I have no more electricity that's going through here. And one thing I want to point out, if we just look at this test tube right here, the column of gas in this test tube is about this far. Whereas in this one over here, it's about half as much. So that means, remember I said that the black is the negative electrode and hydrogen is a positive gas, law of electric charges, positive goes to negative. Therefore, the hydrogen we produce twice as much as we did the oxygen. Think about the formula for water, H2O, we have produced twice as much. Next, I want to point out both of the gases in these test tubes are colorless. We know hydrogen to be a colorless gas. We know oxygen to be a colorless gas. So, other than the fact that we know we started with water, and the law of conservation of mass says atoms are neither created or destroyed in a chemical reaction, which tells us that we can't have anything but hydrogen and oxygen because we started with water. We also know that we have a positive, colorless gas that we produce twice as much as the other one. And so what I'm going to do is I'm going to put my hand in there.
Mr. Wise, are you telling me students would have been able to put their hand in there and do this themselves?
Absolutely, absolutely.
Dang it.
And I am bringing this up here. Notice that I've trapped that gas right there. Now I'm going to keep my thumb over it as I go here, and I've trapped that gas. Now you saw Mr. Dairyman do this with the hydrogen gas that was produced in part 2. We should get the same reaction. Now the difference between that is we've produced what we've produced. We only have one shot, one chance, one opportunity at this. Whereas in the reaction that Mr. Dairyman did, it was constantly, the magnesium was constantly reacting with the hydrochloric acid and he was producing more, so he was able to do it again. So what I'm going to do is I'm going to light this splint, and if this works out, we should get a pop or a whistle. There we go. And I can only do that one time, okay? I got one shot, one chance, one opportunity at that. Now, I'm going to take the oxygen, and I am going to, again, put my hand in here and bring it up, and I've trapped that oxygen. Again, notice it's only half as much as before. But this time, I'm not going to use a lit splint. I'm going to use what's known as a glowing splint. And a glowing splint, what I'm going to do is I'm going to blow this out. Now, the reason for that is hydrogen is an explosive element, which we saw it explode in my hand and in Mr. Dairyman's hand as well. Oxygen is not, but oxygen supports combustion. So I'm going to blow this out, and if we're lucky, it's going to relight it. Now, we only have so much oxygen here. We'll see how that works out. So there I blew it out. It's glowing. See how it brightens up a little bit? Now, that one doesn't show quite as well as the other one. So I'm going to try it one more time with another one of these test tubes. All right, blow it out. It's glowing. And there we go. We relit the splint. That's a positive test for oxygen. So that is the 3 parts of the Energy Reactions Lab.